Thousands of GPUs humming inside a data center the size of a small city. A chatbot answering a question in perfect human sentences. A robotic arm learning to grip an object it has never seen before. Stock tickers flashing the name of a chip company faster than any market had ever priced one before. For a moment, it looks like the future arrived all at once. It didn't. Silence. 20 years earlier, none of this existed. Not the chatbot, not the demand, not the belief that any of it was possible. There was only a decision, one that looked, at the time, like a mistake. For almost 20 years, Wall Street thought this company was wasting its money. Every quarter, analysts asked the same question. Why does a video game chip company keep pouring billions into something nobody is buying? There was no product for it, no customer asking for it, no market that could explain it. And yet, one man kept building it anyway. He wasn't trying to make better graphics. He was trying to change what a chip could think. Decades later, that decision would sit at the center of the biggest technological shift in a generation. But in the years it was happening, it looked like the slowest, strangest bet in Silicon Valley. This is not a story about chips. It's a story about a man who kept choosing conviction over comfort long before anyone agreed with him. Jensen Huang did not grow up around computers. Part of his childhood was spent at a boarding school in rural Kentucky, doing chores most nights, just to keep the building running, learning early to work through what other people give up on. In 1993, he co-founded a company in a booth at a Denny's, betting that computer graphics were about to become the next frontier. They called it NVIDIA. Their first chip failed. Months of cash left. No mercy from the market. They survived, barely. And Jensen carried one lesson out of that near collapse into a decision, years later, that had nothing to do with games at all. In this industry, standing still is how you die. By the mid-2000s, NVIDIA had done what it set out to do. Its GPUs were the standard for gaming graphics, sold by the millions, praised by every major game studio on the planet. By every normal measure, the company had already won. That's exactly when Jensen Huang made a decision that confused almost everyone around him. Picture the scene: a stack of research papers on his desk, forwarded by engineers who almost threw them away. Physicists, chemists, a handful of obscure machine learning researchers, all of them quietly using NVIDIA's gaming chips, not to render images, but to run massive parallel calculations no one had asked the chips to do. Almost no one else at the company saw this as anything more than a curiosity. Gaming was the business. Gaming was the money. Jensen saw something else. If a chip could process thousands of threads simultaneously for graphics, it could, in theory, do the same for nearly any computationally heavy task on Earth. So, he made the bet that would define the next 2 decades of the company. In 2006, NVIDIA released something almost no gamer cared about, and almost no investor understood. A software platform called CUDA, designed to let any programmer, not just graphics engineers, use NVIDIA GPUs for general-purpose computing. It cost billions of dollars to develop and support. It required rebuilding chip architecture around a use case that barely existed yet. It offered no clear return. Inside a conference room, engineers pushed back directly. Why fund a science project with gaming profits? Why shrink the margins that made the whole company work? Jensen didn't have a chart that answered them. He had only a sentence, repeated until it became a kind of company doctrine. He wasn't building for the customers NVIDIA had. He was building for the customers NVIDIA didn't have yet. Customers that, by his own admission, might not exist for another 10 years. They weren't building for the market. They were building for a future no one could see yet. It was the kind of decision that ends careers when it fails and gets rewritten as genius when it works. In 2006, nobody knew which one this would be. Another earnings call. Another analyst asking why margins kept falling. Another quarter where the same question returned, word for word, like a script no one could rewrite. CUDA didn't create an overnight market. It created almost a decade of financial pressure with very little to show for it. Wall Street punished the stock. Competitors mocked the idea publicly. Why would a graphics company think it could compete in general computing? Inside the company, engineering teams spent years building software tools for a customer base that for most of that decade was mainly a handful of university researchers experimenting with early neural networks, an academic curiosity, not a business. Behind the boardroom door, it looked different from how it looked on paper. Picture Jensen, alone in his office after one of those calls. The lights of the building mostly off. A product roadmap spread across his desk that he can't yet justify to anyone watching the numbers. He runs the same projection again. It still doesn't prove anything. He doesn't have certainty. He has a belief and a shrinking pile of evidence to support it. There were board meetings where he had to defend a strategy with no results to point to. Only a conviction that the results were still years away. There were moments, according to people who worked alongside him then, where even he admitted, quietly, that he didn't know exactly when or if the payoff would come. That is a different kind of pressure than failure. Failure has an ending. This had none. Just years of the same question, the same doubt, the same slow bleed of confidence from people who had once trusted him completely, and, some nights, from himself. If deep learning the field that would eventually make CUDA indispensable had turned out to be the dead end many respected researchers believed it was, this decision would be remembered today as one of the most expensive strategic errors in tech history. Jensen Huang kept funding it anyway, not because he had proof it would work, because he had watched, at the beginning of his career, how quickly companies died when they optimized only for what already worked. And some fears are worse than the fear of being wrong. The cost of that decision was almost a decade of doubt, criticism, and sleepless nights paid in full, with no receipt showing what it would buy. The turn didn't happen inside NVIDIA. It happened in a university lab. In Arlie ER, a small team of researchers entered an annual computer vision competition, a contest to see whose software could most accurately recognize objects in images. For years, incremental improvements had been the norm. That year, one team's model didn't improve on the competition. It obliterated it, cutting the error rate by a margin no one thought was possible so quickly. The breakthrough wasn't just a smarter algorithm, it was the hardware underneath it. The team had trained their neural network using NVIDIA GPUs and CUDA, the same platform that had been quietly criticized for years as an expensive distraction. Suddenly, The tool built for rendering video game explosions was the tool that made modern artificial intelligence computationally possible. Researchers who had never cared about gaming chips started buying them by the rack. What had been a graphics company's side investment was now, without anyone officially announcing it, becoming the foundation of an entirely new computing era. Everyone had seen graphics. Jensen had seen computation. The market hadn't changed its mind about NVIDIA. The market had simply arrived, a decade late, at the place NVIDIA had already been building toward. Once the AI research community understood what NVIDIA's chips could do, the shift accelerated faster than almost anyone inside the company had planned for. Startups building early machine learning products started designing their systems around NVIDIA hardware by default. Universities restructured entire research budgets around GPU clusters. What used to be a gaming supply chain was suddenly being fought over by AI labs willing to pay almost any price for access. NVIDIA didn't just have a head start. It had a decade-long head start that competitors couldn't manufacture overnight. Because CUDA wasn't just a chip, it was thousands of software tools and libraries that researchers had built their work around for years. Jensen Huang doubled down again. Instead of treating this as a lucky break to milk quietly, NVIDIA restructured itself around AI computing as its primary identity, investing even more aggressively in specialized data center chips built explicitly for machine learning workloads. Every division of the company began reorienting around the same idea Jensen had been repeating internally for over a decade. Computation, not graphics, was the real business. By the late Arlene Eileen S., NVIDIA's data center business, the same category that had been dismissed as a distraction 15 years earlier, was growing faster than its gaming division ever had. The company that Wall Street once criticized for wasting money on a science project was now supplying the infrastructure that nearly every major AI lab on Earth depended on. They weren't building for the market. They were building for a future no one could see yet. And now the market was lining up to buy it. Then came the moment that turned a specialized bet into an avalanche. In late RR, a new kind of AI product reached the public, one capable of holding conversations, writing text, and generating ideas in ways that felt startlingly human. Within months, it became one of the fastest adopted technologies in history. Almost no one outside the industry realized what sat underneath it. Massive clusters of NVIDIA chips running on CUDA, training and operating a system built on the exact architecture Jensen Huang had bet on in 2006. Demand didn't grow. It didn't even climb. It broke loose an avalanche that gathered speed faster than anyone in any boardroom could model on a spreadsheet. Every major tech company, every government, every ambitious startup building an AI product, all of them, at the same moment, needing the same thing. Waiting lists stretched for months, then for years. Companies that had never once discussed hardware supply chains in public were now fighting over chip allocations like scarce currency, flying executives across the world, offering blank checks just to secure a place in a line that kept growing faster than it could be served. It stopped feeling like a business story. It felt like the entire world had discovered overnight that it was standing on top of an infrastructure it didn't know existed, and there wasn't enough of it to go around. But this moment carried its own crisis, one no amount of demand could solve on its own. Could NVIDIA manufacture enough chips to meet demand that had grown 100-fold almost overnight? Could it maintain the software advantage that made switching to a competitor nearly impossible, while every major tech company on Earth suddenly had the motivation and capital to try building an alternative? Could a company that had spent 15 years as the quiet, criticized outsider survive becoming, almost overnight, the single most important supplier in the entire technology industry, with the whole world now watching every move it made? Jensen Huang's answer was the same instinct that had defined the company since that first near collapse in the Ezhou Julin S. Move faster than comfort allows. NVIDIA restructured its entire product roadmap around annual, not multi-year chip release cycles, an almost unheard of pace for hardware this complex, just to keep the advantage it had spent nearly 2 decades building. Every decision was now being scrutinized by investors, governments, and competitors, all trying to understand whether this company could hold on to a lead earned in near total obscurity. And here is the moment the whole documentary has been building toward. The very thing that once made NVIDIA look reckless, pouring billions into a market that didn't exist, was the exact reason no competitor could catch up once that market suddenly appeared. The decade of criticism hadn't been a mistake investors failed to see. It had been the moat competitors couldn't build in time, no matter how much money they now had. The bet that once looked like the slowest, strangest decision in Silicon Valley had become, without anyone officially declaring it, the single most important hardware decision of the century. Here is the question worth sitting with. If, in Lil, Jensen Huang had listened to the board members who wanted to cut CUDA's funding, if he had chosen comfort over conviction, just once, the AI moment the world experienced in 2022 might not have happened when it did, or how it did, or through this company at all. The world didn't just get an AI revolution. It got one built on top of a decision almost no one agreed with at the time. Today, when people talk about the artificial intelligence revolution, they usually talk about the software, the chatbots, the models, the breakthroughs that make headlines. Few people talk about the chip inside it. Fewer still know about a decision made in 2006, funded through nearly a decade of criticism, with no proof it would ever work. Jensen Huang didn't have a vision of ChatGPT or of the specific AI moment that would justify his bet. What he had was a much simpler belief that computation, not any single product, was where the future was headed, and that waiting for proof before acting was how great companies became irrelevant ones. That is, in many ways, the pattern behind almost every company that changes an industry. The most important decisions rarely look brilliant in the moment they're made. They look expensive. They look unfocused. They look, to almost everyone watching from the outside, like a mistake in progress. NVIDIA's story isn't really about chips, or gaming, or even artificial intelligence. It's about what it costs to keep building something the world isn't ready to want yet, and what happens on the rare occasion the world finally catches up. They weren't building for the market. They were building for a future no one could see yet. If you've made it this far, you already understand something most people miss about how the biggest companies in history actually get built. Subscribe to Built from Zero for the next story, because empires are rarely built by people who wait for permission. Total estimato, 2,850 palabras / approximately equals 19 minutos. de narración.